All right. Department of Energy Fundamental Handbooks Instrumentation Control Volume 2 of 2 U.S. Department of Energy Washington D.C. 20585 Distribution Statement approved for public release. Distribution Unlimited FSC 6910. Department of Energy Fundamental Handbook Instrumentation Control Module 6 Radiation Detectors. Radiation detecting terminology. Electron ion pair. Ionization process with the remove the one or more electron with the neutral atom. Result with the loss of the union with the negative charge of the effect with the atom. The atoms become with the electron with the positive ion products. Product with single ionization event with the call of the electron ion pair. Specific ionization number of the ion pair produced with the per centimeter of the travel through the media with the equation 6 expressed with the relationship. Specific ionization is equal to ion pairs produced over the path length. The special ionization dependent on the mass of the charge, energy of the particle with the electron, is density of the matter with the greater of the mass of the particle with the more interaction with the produced with the given the distance. With the large number of the interaction result of the production with the more ion pairs and higher specific ionization particle charge that has the greatest effect with the specific ionization higher charge with the increase with the number of the interaction which occur with the given the distance and increase with the number of the interaction produced. More ion pair, therefore, increasing the specific ionization as the energy particle decrease with the produce the more ion pair with the same amount of the distance travel. Think of the particle of the magnet is moved over the pile with the paper clip with the magnet attract with the clips. Maintain for the same distance the pile variable speed over the magnet. Note if the slower magnet is passed over the pile over the paper clips. More. Clips being attached to the magnet with the same with the troop of the particles made single of the group of the atom to give it the distance slow particle travel the more atoms effect. With the stopping power of the linear energy transfer or LET is the energy loss per unit path length of the equation 62 expressions of these relationships. S the stopping power is equal to the linear energy transfer equal to the energy loss over the path of the travel. The specific ionization time is with the energy pair. Ion pair yields strong power of the linear energy transfer as shown in the equation 6. The as stopping power is equal to the ion pairs over the path length times the energy over the ion pairs equals to the energy of the path length. With stopping the power of the linear energy transfer proportional specific ionization. Summary: stopping the power is proportional specific ionization for the radiation detection item that's discussed later in the chapter. The summarized below with the radiation detection terms. The summary: the electron ion pair is product with a single ionization event. Specific ionization is the number of the ion pairs produced per centimeter of the travel through the meter of the stop time versus energy loss per unit of the path length. Alright, radiation types. Alpha particle. The alpha particle is a helium nucleus produced with the radioactive decay of the heavy metal with the sum of the nuclear reaction. Alpha decay, alpha the curve of the bond. Nuclei that have the favorable neutron-proton ratio but contain with too many nucleons for stability. Alpha the particle, the mass of the particle consisting of the assembly of the two proton and neutron with the result in charge of the positive two. With the alpha particle with the release of the penetrating radiation many major energy loss of the alpha particle with the electrical excitation ionization. Alpha particle path through the air and soft tissues loss with the average of 3.5 EVs per ion per created due to the highly charged state with a large mass with a low viscosity. Special ionization of the alpha particle is very high. Figure 1 illustrates specific ionization alpha particle ordered of tens of thousands of ion pairs per centimeter in the air. The alpha particle will travel the relatively straight path over a short distance. Alright, this shows the alpha particle specific ionization versus distance travel in the air. Difference travel in the air centimeter over the specific ionization of one ion centimeters. Beta particle. Beta particle is ordinary electron positron ejected with the nucleus. Beta unstable, the radioactive atom of the beta is a single negative positive electrical charge, very small mass of the interaction with the beta particle orbital electron leave with electrical excitation ionization from the orbital electron. The electrons caught with the beta particle to lose energy, the overcoming electrical force orbital electron with electrical force active over along the distance through the therefore two particles that do not have to come in the direct contact with the ionization with the amount of the energy lost with the beta particle depends on both the distance and approach of the electron and kinetic energy. Beta particle with the orbital electrons have the same mass, therefore easily detect reflected in collision because of the fact that the beta particles follow the torus path that passes through the absorbing material. The specific ionization beta particle is lost due to the small mass, small charge relative to the high speed of travel. Gamma ray. The gamma ray is a photon electromagnetic radiation, very short wavelength with a high energy emitted with an unstable atomic nucleus that has a high penetration power. There are three methods of actuation reducing energy of the level of the gamma rays: photoelectrical effect of the Compton scattering and the pair prediction. The photoelectrical effect with the curve of the low energy gamma strip of the orbital electron is shown in figure 2 for the total energy of the gamma that expands for the ejection of the electron from the orbit, the result of the ionization of the atom and the expulsion of the high energy electron. Photoelectrical effect most predominant with the low energy gamma, rarely occur with the gamma that having an energy of the 1 million electronic volts. Photo 2 show the photoelectrical effect of the photon. Photo 3 show the Compton scattering photon. Compton scattering elastic collision between the electron and photon shown in figure 3. Within case the photon has more energy than required to eject the electron from the orbit. It cannot give up all of its energy in collision with a free electron, since all of the energy of the photon cannot transfer. The photon must be scattered. The scattered photon must have less energy long wavelengths, result of the ionization atom of the higher energy beta of the gamma and a gamma lower energy level of the original. Compton scattering is more predominant within the gamma's energy level of 1.2 to 2 million volts electronic volts range. At higher level, the energy levels the pair production of the predominant higher level, the higher energy gamma, the path of the closest enough for the heavy nucleus of the gamma to disappear, the energy reappear with the form of the electron positron, the same in the mass of the electron. However, the positive charge shown in figure 4 with the transformation of the energy into the mass taken place with the new particle with the rest of these nucleus conversion momentum. Kinetic energy recoiling nucleus is very small, but therefore all the photon energy except for the need to supply with the mass of the pairs appear to the kinetic energy of the pair. For reaction to take place with the original gamma, that must have at least 1.02 million electronic volts energy. Show the 1.0.2 million volts energy photon heavy nucleus electron positron 0.5 million of electron volts photon. Electron loss energy ionization positron interact with the electron loss of the energy ionization, the energy of the positron loss of the alpha the NE combined with the electron mutual annihilation. Curve of the energy is relief of the gamma, the probability with the pair with the production curve is significant with the higher energy gammas. Gamma radiation very high penetration power with a small fraction of original stream. Will pass through the several feet of the concrete, several meter of the air with a specific ionization of the gamma that is low compared with the alpha particle with a higher than the beta particle. Alright, your neutrons. Neutrons have no electrical charge. They have nearly the same length of the proton. Hydrogen have the nucleus of the neutron. Time with the time that over the large electron, 1/4 side of the alpha particles. Some of the neutrons primarily nuclear reaction such as fission. But they also produce the decay of the radioactive elements because of the side of the lack of the charge of the neutrons fairly difficult to solve. They have relatively high penetration power. Neutrons make alive with the nuclei containing one of the following reactions: any elastic scattering, radioactive capture, or fission. In the elastic scattering coupled with some of the neutron. Kinetic energy to be transferred to the target of the nucleus for the form of the kinetic energy, some of the internal energy of the transfer energy slope of the neutron between the leave of the nucleus, the state of the excitation energy that is emitted with the gamma of the ray photon interaction between the neutron and the nucleus is best described between the compound nucleus mode of the neutrons captured with the re-emitted with the nucleus along with the gamma ray photon with the re-emission for the considered with the threshold phenomenon of the neutron. Threshold energy vary with the infinity with the hydrogen and inelastic scattering cannot occur with about 2 to 6 million electronic volts for the oxygen, less than 1 million electronic volts for uranium. Elastic scattering is most likely the interaction between the fast neutron and the low atomic mass of numerous absorbed by the interaction, sometimes referred to as the Billy bar, the fact that the neutron share with the kinetic energy of the target nucleus without existing of the nucleus. The radioactive capture takes place with the neutron absorbed with the produce of the existing nucleus. Existing nucleus regains its stability with emitting gamma ray. The fission process of the uranium nuclear reaction, whereby the neutron is absorbed with the uranium nucleus with the intermediate compound uranium nucleus U-236 and U-239 compound nucleus fission with the two nuclei with a fission fragment is simultaneously emission of one or two subatomic neutrons. Fission fragments produce the combined kinetic energy of the 160 million electronic volts for the uranium-235 and 200 million electric volts for uranium-238. With the dissipated causing ionization of the fission reactor that can occur with either faster than thermal neutrons. The distance of the faster neutron will travel between the introduction and the slowing down of the medium of the moderate of the thermalization depend on the number of the collision, but the distance between the collision and through the actual path of the neutron slowing down with the torches. Because of the collision with the average straight line distance that can be determined, the distance is called the fast diffusion length with the slow down length. The distance traveled with the one thermalized until the neutron is absorbed is called the thermal diffusion length. Fast neutrons rapidly degrade with the energy of the elastic collision with the interact with low atomic number of the neutron with the react with thermal and renew thermal energy with likelihood with the capture and improve the present day with the reactor if it's low with the thermalize. Neutron continue with the scatter elastic moderator until they absorb the fuel with the non-fuel material until the leak from the core. Secondary ionization called with the capture of the neutrons important the detection of the neutrons. Neutrons will interact with B10 with produce the lithium-7 and helium-4. Lithium alpha particles share the energy produced with the secondary ionization where it is easily detected. Alright, summary. Alpha, beta, gamma, and neutron radiation summarized below. Alpha particle. The alpha particle is a helium nucleus produced the radioactive decay of the heavy material metal with the sum of the nuclear reaction. The high part of the chart of the alpha particle with the cover the electrical acceleration ionization surrounding items. The beta particle, ordinary electron positron rejected with the nucleus of the beta unstable radioactive atom. Interaction beta particle or orbital electron less for the electrical acceleration ionization orbital electron. Gamma ray. The gamma ray is a photon electromagnetic radiation very short with a wavelength high energy with 3 mass with the actuation gamma ray with a photoelectric effect with the quantum scattering the pair production. Neutrons have no electrical charge, have nearly the same mass of the proton, hydrogen, atom, nucleus. Neutrons collide with the nuclei causing one of the following reaction: inelastic scattering, the radioactive capture, and fission. Our gas-filled detector. The pulse operation gas-filled detector illustrates the principle of basic radiation detection. Gases are filled with radiation detector with the ionized part with the travel that can travel freely through the liquid or solid. The typical gas of the detectors are argon and helium. Although borium trifluoride is utilized with the detector to be used by to measure the neutrons. Figure 5 shows a schematic diagram of a gas-filled chamber with a central electrode. This shows the schematic diagram gas-filled detector insulator chamber wall cathode charged particle with central electrode anoid. Show the DC capacitor resistor circuit grounded. Your central electrode anode collect with the negative charge of the anode that is insulated with the chamber of the wall with the cathode, which collect with the positive charge of the voltage applied with the anode with the chamber of the wall with the resistor, and the circuit is shown with the capacitor in pair wall with the anode with the positive voltage with respect with the detector wall. A charged particle pass through the gas-filled chamber of the ionized some of the gas air with along with the path of the travel of the positive of the anode with the track of the electron negative particles. Detector wall and cathode track of the positive charge of the collection with the charge of the reduced with the voltage, curve with the capacitor, curve with the pulse, curve with the resistor, record with the electronic circuit with the voltage, the amplified with the anode and cathode determine the electric field with the strength. As the detector voltage with increase with the electrical field has more efficient influence upon with the electrodes produced with the sufficient voltage with the cover the causing a cascade effect with the relay with the motor electron through the cathode forward for the electron greater with the main free path with the twin collision result with the reduce of the threshold calculating chamber with the capacitor charge with the yield with the heat with the resulting pulse and the initial capacitor charge with the applied voltage and capacity is given in equation 6. The capacitor charge initial capacitor charge is equal to the applied the capacity time of the applied voltage change in the capacitor charge proportional change with the voltage and the equal to the height of the pulse given in the equation 6, 5, and 6. Alright, you have your initial capacitor charge is equal to the capacitor time of the voltage, and voltage is equal to the initial capacitor charge over the capacity. Total number of the electrons collect with the anode determine the chamber of the charge of the capacitor with the chamber of the curve directly related with the total ionization area event with the curve in the gap of the ion pair with the initially formed by the incident radiation attention for the greater enough of the velocity of second ionization other atoms or molecules or gap of the less solution electrons cover the further ionization of the multiplication electrons determine the gas application gap amplification factor designation increase into the ion pair with the initial ion pair is created the additional ion pair, therefore height of the pulse is given in equation 6, 7. The pulse height of the volts is equal to the gas amplification factor times the initial ionization events times the charge of the electron in 1.062 times 10 to the negative 19th power columns and over the detector capacitance in farads. The pulse height it can be computed with the capacitance detector character of the radiation known with the capacity is normally about 10 the negative 4 farad. The number of the ionization may be with the calculated detector side of the specific ionization ring with the charged particle known with the only variable gas amplification factor dependent on the applied voltage. Summary of the operation gas field detector summarized below. Your gas-filled detector system summary with the central electrode anode with the electrostatic collection of electron ion pair with the chambered wall with the direct and collect with the positive ion. When applied voltage is high enough, the ion pairs that initially formed will accelerate with a high enough velocity to the secondary ionization of the result of the ionization called with further ionization multiplication of electrons called with gas amplification. or detector voltage. Amplified voltage. The relationship between the applied voltage pulse height with the detector is very complex with the pulse height and the number of the ion pair with the collective. The directly related figure 6 for the illustrator of the ion with the pairs collective with the verse for the applied voltage. Two curves are shown, one curve of the alpha particle, one curve of the beta particle, each curve is divided into several voltage region. The alpha curve of the higher, with the beta curve of the from region 1 to part region 4 with the due with the large number of the ion pairs produced the initial reaction the incident radiating from the alpha particle will create more ion pair for the beta since the alpha that has more greater mass. The difference between the math negated only the detector voltage for the increase of the region 4 with the detector completely discharged within each for the initial initiating event. Alright, this shows the number of the pairs in effect for the alpha 10 to the third, 2 to 6, 9, 12, and 15. The applied beta is across the bottom. Applied voltage is 200, 400, 600, 800, 1000, 1200, 400, 1600. Regions 1, 2, 3, 4, 5, and 6. Recombination region, ionization region, proportional region, limited proportionality, Geiger-Muller region, and continuous discharge region. Recombination region. In the recombination region 1 with the voltage increase, the voltage 1 is the pulse height with the creep of the breach for the saturation at the voltage 1, the field strength between the cathode and anode sufficient with the collection of the ions produced with the detector. All voltages left within voltage 1 ions must be slowly turned toward the electrode of the ions 10 with the recombine with the neutral atom of the nucleus or neutral atoms in the molecule. In case of the pulse height with the left then would have been with the originally formed with the reach of the electrode. The ionization instruments are therefore not operating with the regional response. Ionization region. The voltage increase of the ionization region 2. There is no appreciable increase of the pulse height of the field strength, but more of the adequate with the ensure the collection of all the ions produced, however, the insufficient to cover the increase of the ion pairs due to the gas amplification in this region cover the ionization chamber. Proportional region. The voltage increase of the proportional region 3 with the pulse of the height with the increase of the voltage with the insufficient produced with the large potential gradient near the anode, then part with the very high velocity of the electron produced with the ionization with the gas by charged radiation particles. Velocity of these electrons is sufficient for the ionization of the other atoms molecule with the gas multiplication of the electron cast application is referred to as the Townsend avalanche. The gas amplification factor A varies from 10 to the third to 10 to the fourth of the region. Called the proportional region since the gas amplification factor is proportional to applied voltage. Limited proportional region. In the limited proportional region, region 4 with the voltage increase with additional profit, the curve of the lead with the increase of the ionization strong field with the increase of the electron velocity, which will result of the excited side of the higher energy capable of releasing the more electron with the cathode. The events of the Townsend avalanche are spread along with the anode with the positive ions remaining near where they were originated, reduce the electrical field with the point with the avalanches in palpable for the region. The region 4 is called the limited proportional region. It is not either detector operation. Geiger-Muller region. The pulse height of the Geiger-Muller region with the region 5 of the independent type of the radiation cover the initial ionization. Pulse height of the obtained with the order of the several volt of the field strength with the degree of the discharge of the ones to ignite with the continuous spread until the amplification cannot occur due to the density of the ion and sheath around the central wide anode value. Voltage 4 is termed the threshold voltage where the number of the ion pair of the level off the remain relatively independent of the applied voltage. This leveling off is called the Geiger plateau, which extends over the region of 200 to 300 volts of the threshold with normally about 1000 volts. The Geiger-Muller region is the gas amplification factor dependent on the specific ionization radiation detected. Continuous discharge region. In the continuous discharge region, region 6, the steady discharge current flow with the applied with voltage so high that once ionization takes place with the gas, there is a continuous discharge electricity, so the detector cannot be used for the radiation detection. Alright, radiation detectors normally designed with a response certain type of the radiation for the detector respond with the sensitive to both their energy with the intensive radiation. These type of the detector defined with the operation limit the base for the character of the radiation measured with the large frequency detector with the use of the department energy facilities. Detect alpha and beta particle with the gamma and the ray for the neutron. Some of the type of the detectors capable of distinguishing between the type of the radiation and other notes, others are not. Some of the detectors only can count the number of the particles to enter for the detector, while the others determine both the number of the energy of the incident particle. The most detector of the department energy facilities have one thing in common: they respond only to the electrons that produce in the detector. In order to detect the different type of the indicated particle, the particle's energies must be converted into an electron detector. The gas field detectors are used for most common parts of the measure alpha and beta particles, neutrons, gamma ray. The detectors operate from the ionization portion of the Geiger-Muller region within the arrangement with the most sensitive of the type of the radiation measured for the neutron detectors. Utilize the ionization chamber for the proportional of the counter with the appropriate design of the commutator with the ion chamber, the BF3 counters, the fusion counter with the proton recall counters, example the neutron detectors. Alright, some of the alpha curve with the higher with the beta curve with the region 1 through part with the region 4 with the due to detect the large number of the ion pair for the produce of the initial reaction of the incident radiation detector the voltage prior ionization summarized below. Gas amplification region in summary. The recombination region of the voltage is such so low that the volume recombination takes place but much below the negative ions collected with the electrode. Ionization regulate region. Voltage is sufficient enough to ensure all ion pairs produced by the incident radiation collected. No gas amplification takes place. Proportional region. The voltage is sufficient to ensure the ion pair due to the incident of the radiation collected with the amount of the gas amplification proportional to the applied voltage. Limited proportional region has the voltage increase the additional process of the curve of the leading of the ions. Increased ionization since the positive ions remain near the point of the origin. Further avalanches are impossible. Geiger-Muller region. The ionized ion pair with reduction independent radiation cover the initial ionization field strength with a rate so great that the discharge of the spread of the interval of the amplification cannot cover due to the density. Present positive ion sheet with the surrounding the central wire can do with the discharge read and applied with voltage so high that once the ionization takes place with the continuous discharge of electricity. Alright, proportional counter. The proportional counter is a detector which operates with the proportional reason shown with the figure 6 of the figure 7 and illustrated with a simplified proportional counter circuit. To be able to detect with a single of the particle with the number of the ion with the produced the most increase the voltage increase it into the proportional read the primary ion with the required energy to cover the second ionization gas amplification increase the charge for the collective with the secondary ionization may be further ionization. Figure 7 shows the proportional counter, shows the dial and a DC. In this region, a linear relation between the number of the ion pairs collected with applied with the voltage charge amplification 10 to the fourth can be attained with the proportional region by a functional arrangement with the modification biasing with the potential proportional countering may be either to direct detect alpha, beta, gamma, and neutron radiation mixed with the radiation fields. To the limited degree, the field gap determined the type of the radiation, the proportional counter will be able to detect argon and helium, or most frequently, either the field gas allowed with the detection alpha, gamma radiation detection with a neutron necessary for the detectors usually filled with a boron trifluoride gas. Simplified circuit with the illustrator in figure 7 that show that the detector will acts on the one electrode by the other electrode in the fine wire center of the chamber of the positive voltage applied. Figure 8 illustrates how the number of electrons collected varies with the applied voltage. The number of electrons collected over the voltage 500, 100, 1000, 1500, 10 to the 4th, 10 to the 5th, 10 to the 6th, ionization, recombination region, ionization region, proportional region. With a single gamma ray that interact with the gas chamber that produces the rapidly moving electron, produces the secondary element electron with the 10,000 electrons may be formed depending on the gas used with the chamber. Where the applied voltage increase the amount with the recombination area low with the further increase of the incredible do not appreciable increase the number of electrons collected. The region in which the 10,000 electrons are collected with the ionization region. This applied voltage is increased to 1,000 volts. The number of electrons become greater than initial 10,000 additional electrons which are collected due to the gas amplification. As the voltage is increased with the velocity of the 10,000 electron produced increased. However, the beyond with a certain voltage, the 10,000 electrons are accelerated in such a speed that they have enough energy to cover the more ionization. The phenomenon is called gas amplification. Example of the 10,000 electrons produced for the gamma ray increased with 40,000 by the gas amplification factor, but would be 4 with the gas amplification factor can range from the unity ionization region 10 to the 3rd to 10 to the 4th proportional region. Higher amplification factor proportional counter with major advantage for the ionization chamber. The internal amplification proportional counter with the lower energy particle is less than 10 kilo electrovolts. Register of the ion chamber, they're limited to the amplifier noise particle of greater than 10 kilo electrical volts energy. Proportional counter is extremely sensitive to the voltage and large enough that these electrons collect with a few tenths of the microsecond without each pulse for the corresponding with the gamma, the ray, neutron, and interacts the amount of the charge of each pulse with the proportional number of the original electrons produced with the proportional factor. In this case, the gas amplification factor, the number of the electrons produced with the proportional of the amplifier energy with that including particle. For each of the electron collected in the chamber, the positive charge of the gas flow ion left over the gas ion with the habit compared with the electron move with the much more slowly. Eventually, the power of the ions move away with the positively charged center with the wire with the negatively charged with the wall with the neutralized with the gain of the electron with the process with some of the energy given off with the cover the additional ionization gas atoms the electron produced with the ionization the more toward the central wire with the iron multiplied in route with the pulse with the charge with the unrelated radiation the detector with the can set off the other series the pulse must be eliminated quenched. One method of quenching with these Detectors to add a small amount of about 10% of the organic, approximately 10% of the organic gas such as methane and sugar. They quench with the gas of the molecule of the weaker affinity for the electron of the chamber of the gas, and therefore the ionization chamber of the gas readily take with the electron for the quenching of the gas molecules. The ionization molecule with the quenching of the gas read with the chamber, instead of the chamber of the gas, the ionized molecule with the quenching of the gas, the ion neutralized, and the gassing electron energy liberated, but does not cover the further ionization, but the dissociation of the molecules, dissociation, quenching the multiple discharge of the quenching of the gas molecules eventually consumed, limiting the lifetime of the proportional count. However, some of the proportional counts have the indefinite lifetime because of the quenching gas is constantly replenished. The counters are referred to as gas flow counters. Summary proportional counters are summarized below. Proportional counters when the radiation is a proportional counter of the detector gap to the point where the incident radiation becomes ionized. Detector voltage is set by the electron could be called the second ionization accelerator toward the electron. The electron produces the secondary ionization called the additional ionization. The multiplication of the electron is called the gas application. Verification of the detector voltage of the proportional region. The decrease of the gas amplification factor. Quenching of the gas is added to given an electron chamber for the gas through the inaccuracy not introduced due to the ionization caused by positive ions. Proportional counter circuitry. Proportional counter measure for the charge is produced with the electrical particle radiation take control of the current capability necessary to measure the number of the pole for the charge of each of the pole with the figure 9 show the typical circuit of the use to make sure of the measurement. Single charge pole with voltage pulse, bigger voltage pole with large pulse. Proportional counter, capacitor, amplifier, single channel analyzer, scalar, timer, resistor, and ground. The capacitor converts the charge of the pole with the voltage is equal to the amount of the charge divided by the capacity of the capacitor given in 6A. The voltage is equal to the charge over the columns over the capacity in farads. Preamplifier, the voltage pole with the further amplification obtained the same with the signal of the amplifier circuit with the typical 10 volt maximum of the pulse side with the determined single channel analyzer. Figure 10 show the original operation with a single channel analyzer input window 0.2 volts and level of 2.0 volts. Single channel analyzer 2 dial set with the level of dial with the window dial for the example the level of the set with the 2 volt with the window at 0 and 2/10 of the volt. The analyzer will give the output pulse with the input pulse between 2 and 2.2 volts. Output pulse is usually standardized height with width of the logic pulse shown in figure 11. Figure 11 shows the single channel analyzer output, single channel analyzer 6.0 volts time interval. Since the signal channel analyzer can be sent with the output with the only produced with a certain pulse with the provided with the count with the specific radiation makes the radiation field the output with the set with the scale with the count with the number of the pulse with the receiver with the time with the gate with the scale with the scalar counts with the pulse with the predetermined length with the knowing with the number of the count with the given time and the interval allowed with the calculation count rate the number of the counts rated per unit with the proper counters that also control and count the neutrons introduced in the boron into the chamber. The most of the common means for introducing the boron combining the triofluoride gases of boron or boron triofluoride BF3. The neutron interact with the boron atom with the alpha particle but is emitted with the boron triofluoride counter made sense of the neutrons not to gamma rays. The gamma rays can be eliminated between the neutron of introduced alpha particle to produce more ionization gamma rays produce. This is due mainly with the fact that the gamma ray induced with the electron have much longer range for the dimension of the chamber. The alpha particle energy with the most capable greater gamma rays to produce the reactor. Therefore, the neutron pulse with much larger the gamma ray produce the pulse. By using the discriminator with the scalar can be used readily and read only the larger pulse with the produce with the neutron. The discriminator basically single the channel analyzer only one with the setting. Figure 12 to illustrate the operation discriminator. Discriminator set to 2 volts. The angle of the inputs less than or greater than or equal to 2 volts cause the output pulse. Figure 13 show the typical circuit used to measure the neutrons with the boron triofluoride proportional counter. Discriminator 2 volts time interval. Discriminator output 6 volts time interval. Boron triofluoride grounded with the resistor, the DC supply grounded, the capacitor, preamplifier, amplifier, discriminator, scalar, and the timer on the scalar. Alright, boron trifluoride, the proportional counter, the U with the minor level, lower level of power level of the nuclear reactor, U with the most over level, the sort of the range of the channel. The proportional counters cannot be U with the higher power level because of the they have any pole with the detector typical with the 10 to 20 microsecond with each of the pole with the given 10% with the peak to peak and then back to 10% with another neutron interact with the chamber during the time. 2 poles are superimposed. The voltage output would never be dropped to 0 between the 2 poles, but the charge would be drawn at the steady current with the electrons being produced. Summary. Proportional counter circuitry is summarized below. Proportional counter circuitry summary. The proportional counter measures the charge of the produce each of the particle. Radiation preamplifier, amplify the voltage used pulse to usable size. The single channel analyzer the discriminator produces the output of the only with the input of the certain the pulse size. Scalar count with the number of the pulse received during the predetermined length of the time and the timer produced the gating signal to the scalar. Ionization Chamber. The ionization chamber electrical device detection radiation voltage adjusted to the condition corresponding to the ionization region of the region 2 with the figure 6 of the chain charge obtained with the result of the collection ionization ion produced with the radiation. The charge will depend on the type of the radiation being detected with the ionization chamber. The 2 distinct disadvantages compared with the proportional counters, they are less sensitive than they have the slow response time. There are two types of ionization chamber to discover: the pulse counting ionization chamber, integrated ionization chamber, the pulse counting ionization chamber, the pulse with the detector with the two particles transferring the chamber, the integrated chamber, the pulp of the average, the integrated total of the ionization produced with the predetermined period of time measured. The same type of ionization chamber may be used either function. However, the general rule, integration time of the ionization chamber, the use of the flat plate with concentric cylinders may be utilized with the control of the ionization chamber, the flat plate with the preferred as well to define the atomic active value with ensure the ions will collectively insulate with the cover the distortion of the electrical field. The concentric cylinder does not have the well-defined active well volume that may cover the variation of the electrical field insulated approach. Ionization chamber, the construction differs from the proportional count of the flat plate with the concentric cylinder by cylinders central electrode to they allow the integration pulp of the produce of the incident radiation. Propulsion counts will require the such the exact control of the electrical field and between the electrodes that would not be practical. Figure 14 illustrates the sample ionization circle with consistently two parallel plates with the metal within airspace between them. The plates are considered unconnected to the battery, which is connected in series of a highly sensitive ammeter. The emitter is extremely sensitive to the ammeter of the electrometer. The radioactive source of the emitter with the particles is placed between the detector and the beta. Particles are passed between the plate with the strike of the opposite area. There's sufficient energy for the bed with the particle to cover the electron to be ejected from the atom of the air. With a single bed with the particle may be ejected with 40 to 50 electrons each for the semi of the path over the length of the travel of the electrons. Inject with the bed with the particle to often have enough energy to eject more electrons over the other items over the air within the air. The total number of the electrons produced depends on the energy of the bed particle with the gas between the plate of the ionization chamber. The general, the 1 million electrical volt beta particle is ejected approximately 50 electrons per centimeter with the travel, while 500 of the million electrical volt beta particle will approximately 300 electrons of the lower energy particle. The lower energy beta ejections, more electrons become the more collisions of the electron. Each electron produced with the beta particle will travel through an air will produce the thousands of the electron current with the 1 microampere, consisting about 10 to the 12 electrons per second. If 1 volt is applied with the plate with the ionization chamber, the shown in figure 14, some of the 3 electrons are trapped with the positive plate with the detector. The attraction is not strong enough because the 1 volt does not decrease the strong electric field between the two plates. The 3 electron will tend to drift over the positive plate with the current to flow with the indicate with the ammeter. All of the 3 electrons will make with the positive plate because of the positively charged the atom as a result of within the electron. When the electron will be ejected and may be recaptured from the 3 electrons, therefore ammeter will recharge with the fraction of the number of the 3 electrons between the plates. When the voltage increases, the 3 electrons more strongly attract with the positive plate, they will move over the positive plate more quickly than left the opportunity to combine positive ion. Figure 15 shows the plot with the number of electrons measured for the ammeter function of the applied voltage. Figure 15 is recombination ionization region. Voltage on the bottom, number of electrons detected, 20,000. Region of the recombination. Then the dotted line, all electrons produced that are detected flat portion of the ionization region. At 0 voltage, no attraction of the electrons between the plate with the curve of the electron will eventually recombine with the surface with no current flow. With the applied voltage increase the positive plate with the bill begin to attract the 3 electrons more strongly. Higher percentage will reach the positive plate with the voltage increase. The further point will reach with all of the electrons produced with the chamber with the reach with the positive plate. Further increase the voltage has no effect with the number of electrons collected. Simple ionization chamber. The figure 14 shows that can be utilized with detection of the gamma rays since the ammeter sensitive that only the electron of the gamma rays may interact with the atoms between the plates to release the electron of the gamma rays interact with the constant scattering photoelectric effect and pair production. Easier for the interaction causes all of the energy incident with the gamma ray to convert with the energy of the ejected electron of the electrode. Ejected electrodes move with a very high speed with the cover of the other electrons to be electric for the atom. All of these electrons can be collected by a positively charged plate in the measured ammeter. Plates of the ionization chamber are normally enclosed in metal and shown in figure 16. Metal case insulated electrical meter. The metal chamber serves to shield the plate of the outside electrical field to contain the air with the other gas of the gamma ray. Have little trouble with the penetrating of the metal wall of the chamber. The beta particles of the alpha particles, however, they're stopped with the metal wall. Alpha and beta particles are detected. Some of them being provided with the wall of the door of the window. This window must have enough from alpha and beta particles to penetrate. However, the window almost to the thickness of the prevent alpha particles from entering the chamber. Here, neutrons can also be detected at ionization chamber already unknown, but the neutrons are uncharted, therefore the new ionization themselves, the inner surface of the ionization chamber, the code with the thin code with the boron following reaction takes place. Neutron is captured with the boron atom energy, alpha particles made with the alpha, the particle is ionization of the chamber, they're injected the X electron further secondary is ionization. Another method for detecting neutrons out of the ionization chamber to use the gas boron trifluoride instead of the air in the chamber Incoming the neutralized produce the alpha particle that will react with the boron atom to the detector gap. Either method may be used to detect the neutron nuclear reactor neutron detectors. When using ionization chamber, the detecting neutron with the beta of the particle to prevent with the entering the chamber, the wall thick enough to shield out with all the beta particles. The gamma rays cannot be shielded from the detector. Therefore, always contribute the total current of the reading of the ammeter. This fact is not desired because the detector responds not only to neutrons but also to the gamma rays. Several ways available to minimize the problem. Discrimination problem possible with the ionization produced the alpha particle with different energy for the level of the gamma rays 1 million electrical volts alpha the particle with moving the gap the velocity of the energy with a few centimeters. Therefore, all the secondary elements, secondary electrons are produced along the path of the few centimeters. The 1 million electronic volt gamma ray produces 1 million electron long range loss of energy of the entire length of the range of the makes sense if the volume of the chambers are small, but the reducing the area of the corroded boron sensitivity of gamma rays is reduced. Figure 17 illustrates how the chamber modified to accomplish reduction. Surface area, sensitive volume, sensitive volume, volume over 2, and your gamma ray influence. In figure 17b, with a half of the much of the gap of the incident volume of the chamber, the figure 17a, the result of the gamma of the rays have only half of the much of the gap of the interact. Therefore, the half of the number of the electrons produced with the air with the boron corroded that does not change both of the chambers do with the same with the number of the neutron induced the alpha particle with the gamma of the ray with the induced electron produced through the few ionization because the range of electrons longer than the dimension of the sensitive volume of the range of the neutron induced the alpha particles short with all the energy dissipate with the sensitive volume even when the volume is smaller. Gamma rays interference can also be minimized, reducing the pressure for the gases introduced in the chamber. The reduction pressure reduces the number of the atoms of the sensitive volumetric volume. Same effect with the reducing of the volume. The ionization sensitivity chamber of the gamma rays can also be reduced. The increase in the chamber, the sensitivity of the neutron accomplished increase of the boron-coated area that is shown figure 18. Both ionization chambers shown figure 18 have the same sensitive volume. Boron lighting electrometer, boron lighting electrometer. Ionization chamber, the figure 18 is the swipe of the boron air with the ionization chamber, the figure 18A with the result of the neutron induced the alpha particle to produce the neutron sensitive to increase the ionization chamber the supply to commercially designed and minimize gamma sensitivity. Both of the techniques described previously, gamma sensitivity can be minimized but not eliminated. The factor reactors operating near peak power neutron but dominate with the radiation. Almost all of the currents due to the neutrons. The chambers are used at high reactor powers with the refer with the uncompensated ion chamber is not suitable for the intermediate lower power level because of the gamma response with all the 3 power levels of significant pair with the neutron response. Summary. Ionization chamber summarized below. Ionization chamber summarized. When radiation entered the ionization chamber, the detector gas points out the incident radiation between the ionization. Some of the electrons have sufficient energy to cause additional ionization. The electrons are checked the electrode by a voltage potential set up on the detector belt, which is high enough of all the electrons to reach the electrode before recombination takes place. Gamma sensitivity reduction accomplished by the reducing amount of the chamber of the gap with increasing boron-coated surface area. Compensated ion chamber. Compensation of the response of the gamma, the extent of the use of all the range of the ionization chamber, the ionization chamber, the consider the 2 separate chambers, the 1 chamber that is coated with the boron, 1 chamber that is not. Coated chamber that sends to both the gamma rays, neutron with the uncoded chamber that sends the one only to the gamma rays. Instead of having 2 separate and with the subtracting with these chromatics done electrically, net output both detectors read on the single ammeter with the polarity of the range for the 2 chamber, the current output with the one and another reading obtained with the ammeter to indicate the difference between the 2 currents. One plate compensated with the ion chamber, the common both of the chamber, the one side with the code with the boron, while the other side with the not. The figure 19 show the basic circuitry, the compensated ion chamber, show the battery boron lined linear AB unlined electrovoltmeter, AB electric meter. Are the boron-coated chamber, the refer of the working chamber, the uncoated chamber, it's called the compensating the chamber, the explode of the gamma, the surface of the battery of the working the chamber, the will sail with the current flow with the deflectors meeting. In one direction, the compensating the chamber, the battery will sail with the current flow with the deflect with the mean with the opposite direction. The both chamber, the identical for the both of the areas, the same voltage. And the net current flow is exactly 0 for, therefore, compensating chamber, the cam for the current due to the gamma ray, the 2 chamber, the compensator, the ion chamber, the never truly identical. In fact, they're alphabetically constructed with a different shape of the chamber, the normally constructed with the concentric cylinders, illustrated in figure 220. Compensated ion chamber, the concentric cylinders, ended the U shown with the 2 chamber, the compensator, the ion chamber, the positive 2 battery is split with the adjustable on the ammeter, line chamber, the working, and the unlined chamber, the compensating. The use of the concentric circuit cylinders advantage of both chambers, especially with the nearly the same radiation, even though the chamber does not technically proper selection of the operating voltage of the limiting the gamma current with the working chamber. The operating of the voltage given the manufacturer's leg with the cover of the current operation of the flat portion of the response curve, the wear with the layer little recombination curve. Working chamber over the voltage, increase the operating with the voltage, compensating with the voltage, let zero with the dimension for the current, will do with the gamma, only with the working chamber, the release and compensating voltage while the reactor is shut down with the minimum number of electrons are present. A compensating chamber, the voltage of the rate, with the measure of the current, with the degree of the more, within current, with the working chamber, the can for the current, with the compensating chamber, but eventually the voltage with large enough to so that the two currents can allow the current of the can for the chamber, the server to be 100% compensated with the measure for the current is 0 with 100% compensated for the detector will respond to the nucleus to neutrons alone. Compensation chamber that usually has slightly higher level, larger sensitivity value of the working chamber. They include the compensation chamber with a very low voltage value greater than the working chamber. The current, the result of the negative current, the condition of the chamber, the server to be overcomes the compensating chamber, the cancel to be measured for the current. Working chamber, the meter reads low, but the incapable compensating chamber, the cancel out over the gamma of the ray current through the neutron current. Percent of the compensation compensated with the ion chamber to give it the percent of the gamma of the rays which are canceled out. The percent of the compensation may be calculated based on the measured current with the detector exposed with the gamma of the rays only, and give it the equation 6-9. Percent compensation is equal to 1 minus the measured current in milliamperes over the measured current, and the compensating voltage off milliamps times 100%. If the measured is 0 with the percent of the compensation, 100% of the measured current is powered with the percent of the compensation less than 100% of the chamber is under compensated. If the measured current is negative, the percent compensation is greater than 100% of the chamber is overcompensated. Ionization chamber, the compensation figure 21 with the plot with the percent of the compensation, with the variance for the compensation volt with the compensation curve with the ability to apply with the power with the compensation ion chamber, the ideal situation compensation ion chamber of the 100% compensation indicated the current with the neutron with the small chamber, the compensation current. Compensation voltage chamber, the percentage voltage, the percentage over the compensation 0, 110, 100, 190, 80, 70, 60, and compensating voltage 100, 200, 300, 400, 600. Operating voltage is negative 420 volts. Source of 1 Curie comb 680. All right, in a minute.
All right, because I need to keep the receipt if they don't fit.
All right. Consequently, operating with the overcompensated uncompensated chamber, the important with the purpose of the nuclear instrument with the detector with the measure of the neutron level with the direct with the measure of core power with the if the compensating voltage is set with the high with the overcompensating with the neutron current. If all with the gamma current with the block with the indicator of the power low with the actual core power with the compensated with the voltage too high uncompensated. Not all of the current low current is blocked. Indicating power with an actual core power with higher power with gamma flux relatively small but compared to neutron flux with the effect of the improper compensation may be not noticed. It is extremely important, however, the chamber to properly be compensated during the reactor startup and shutdown. Summary: compensated ion chamber, the summarized below with the compensated ion chamber. Summary: the compensated ion chamber, the two centric cylinders boron coated with the chamber, the uncoated chamber. Both gamma and neutrons interact with the boron coated chamber. The only gammas interact with the uncoated chamber. The voltages of each of the chamber are set with the current from the gamma in the boron coated chamber that cancel through the current of the gamma in the uncoated chambers. All right, electroscope ionization chamber. We're going to pause the tape. All right, electroscope ionization chamber. The gold leaf electroscope that is with the ionization radiation. The first minute, the property of the ionization radiation was accomplished with this instrument. A microscope containing the graduated scale of the eyepiece that you observe the gold leaf with the newest electroscope that you the quarterized fiber that has many of the veins of the gold over the gold leaf type. The portable left depending on the position, much smaller on the side, the more sensitive the capacity with the coarse fiber to electroscope that you can do about 2.2 of the picofarad. The voltage sensitivity is about 1 of the voltage per division of each of the on the scale. Sensitive element of the fine gold plate with the coarse fiber mounted on parallel metal support with figure 22 illustrate the quarter fiber electroscope. Eyepiece microscope charging button 200 volt DC red lead objective lens ground black lead. Aluminum can 0.5 millimeters wall insulator glass window ionization chamber air gold plated quartz fiber 3 to 5 diameter supporting arm charging contact and spring. A small piece of the quartz on the crop at the end of the gold plate with the quartz fiber, and conservative is the end of the view of the microscope, the quib of the eye scale, the view of the quartz fibers to show the very press with the charge and keep the quartz fiber is being charged, and it deflects from the support, but it takes about 200 volts to produce the full scale deflection with the fiber, the glass window over the end with the ionization chamber allow the full exposure of the fiber that is the gas ion of the incident radiation fiber move the door with the position 0 charge of the electron dependent. Ability, simplicity, accuracy, sensitivity, the widely of the gamma radiation measurement. Self-reading pocket with a dosimeter, for example, the electroscope ionization pocket with a dosimeter provided the person with a meaning with the monitoring of the radiation exposure. The dosimeter is available depending on the range of the gamma exposure from 0 to 200 micro integrants. From 0 to 100 reto integrants, sensitive to the instrument determine the time of the manufacturer product and the scale marking provided each of those dose range. Summary: the operational electroscope ionization chamber is summarized below. Electroscope ionization chamber summary: the electroscope ionization chamber is charged by charge using a battery. Charging cover the quartz fiber to be detected from the support when the radiation ionization of the gas ion in the chamber and the charge is produced. The fiber moves over the zero charge position. Alright, Gall-Miller detector. The Gall-Miller detector GM detect the radiation detect with the operative of the region 5 with the Gall-Millimeter shown with figure 23 with the Geiger-Muller detector produced with the large pulse of the other type of the detector that have with the discrimination not possible since the pulse of the high with the independent with the type of the radiation counts the system. The use of the Geiger-Muller detector is not complex with the using with the ionization proportional counters. Should the number of ions in pairs deflect the alpha from 0 beta and alpha lines 0 to 10 third, 6 to 10 ninth, 10 to 12, 10 to the 15th. 1, 2, ionization region, proportional region, limited proportional region, Geiger region, and 0, 200, 400, 600, 800, 100,000, 1200, 1400, 1600 apply voltage, gas ionization curve. The number of electrons collected with the gas field detector vary with the apply with the voltage. Increase the ones with the voltage, increase beyond the proportional region, then another flat portion of the curve is reached for the known with the Geiger-Muller region. The Geiger-Muller region has two important characters: the number of the electron produced with the independent applied voltage, the number of the electron produced with the independent number of the electron produced with the initial radiation. Means of the radiation producing one electron will have the same side of the pole with the radiation produced with the 100th of the 1,000th electron with the region of the characteristic related to the way the electrons collected the gamma produced the electron. The electron moves rapidly towards the positively charged with the central wire with the electron meet with the new near the wire with velocity and the same point with velocity given the radius great enough to cover the additional ionization electrons approved with the central wire with the additional ionization approved with the larger number of the iron electrons with the same with the central wire. As discussed before, the failure that each of the electron produced with the positive ion produced with the applied with the voltage with increase with the number of the positive ion with the new central wire and keep the positively charged called the cloud called with the positive ion sheet with the form of the round with the central wire with the positive ion sheet with the produce the field strength with the central wire prevent the further electron from the reaching with the wire with the might appear with the positive ion sheet with would increase the effect of positive central wire, but it is not true with the positive potential applied with the very thin central wire that makes the strength of the electrical field very high. Positive ion sheet that makes the central wire appear with the thicker and reduce the field strength with the phenomenon discovered with the detective is space or charge with the positive iomatic group with the torque with the angle of the chamber, the picking up with the electrons as in proportional to counter with the transfer of the electron can relieve the cover of the ionization and liberation of the electron in order to prevent this secondary pulp of the quenching of the gas and achieve the usually an organic compound. The Geiger-Miller counter can produce more electron than the depth of the proportional counter, therefore it much more sensitive to devices often use the detection of low level of gamma rays, beta particles with the retrieve of electrons produced with the Geiger-Miller tube, the collective of the very rapidly usually fraction microsecond with the output of the Geiger-Miller detector is pulse charge often large enough to drop the meter without additional amplification. Because of the same side of the pulp to produce the regular regardless of the amount of the initial ionization, the Geiger-Miller counter cannot be distinguished radiation different energy type of the degrees of the Geiger-Miller counters are not acceptable to use the Neutron detector. The Geiger-Miller detector is mainly used the portable instrument due to the sense of the simple confounding print circuit with the ability to detect low level of radiation. Alright, summary. The operation of the Geiger-Muller detector summarized below. The voltage of the Geiger-Muller detector is so that it is into the radiation produced with the same number of electrons. As long as the voltage remains in the Geiger-Muller region, the electron production with the independent without operating voltage and the initial number of the electron produced with the instant radiation. The operation voltage can couple the large number of the ionization occur near the central electrode electrons approach and the large number of the positive ions with the positive ion sheet which prevent the additional electrons from reaching the electrode. The quenching gas is used in order to prevent the secondary pole to do the ionization by positive ions. Or your scintillation counter. The scintillation counter is a solid-state radiation detector with a use of the scintillation cross for a phosphor that defects of the radiation produced for the light purpose of the figure 24 is an important explanation of the scintillation counter operation. As radiation interacts in the scintillation center, crystal energy for the transfer of the bound with the interaction with the central crystal atom with the energy of the transfer of the grave of the ionization energy for the energy and electron energy for the conduction band with the free with the binding force with the atom with the level. Leave the vacancy with the valency band with the N-terminus over the if the energy transported left with the binding energy electron is attached to the existing side with the energy state. Once again, the whole is created with the valency bound by the adding impurities during the growth of the scintillation crystal. The manufacturer is able to produce the activator excited with the energy level located in the forbidden energy gap. The activator centers can trap the mobile electron rate with the activator because with the ground state with a G to an excited state with a G. E. When the center D excites, the photon is emitted to the activator center. The scintillation crystal is referred to as luminescent center. The emitted photons are visible region of the electromagnetic spectrum. Shift the energy going up on the right E and G, the activator center with the forbidden band, the excitions, and the excitation band, conduction band, hole and filled valency bond, other forbidden filled bands, and electrons. Dot. Scintillation counters the construct with a couple of soluble scintillation phosphor, the light sensitive photo multiplier tube with the figure 225 illustrates the example of scintillation counter used for the thallium activated sodium iodide crystal. Sprayed aluminum oxide, aluminum 2 oxide, aluminum 2O3 reflector, the NaLTI crystal packed aluminum O2 reflector, optical window, optical coupling fluid, spun aluminum coupled aluminum body, MU multiple, MU metal magnetic shield type, the 6292 photo multiplier. There are three classes of solid-state scintillation phosphor: the organic crystal with the inorganic crystal, plastic phosphor. The inorganic crystal is included with the lithium band, with the sodium ion, with the cesium ion, with the zinc, with the sulfide. With the inorganic crystal with the character of the high density, high atomic number, the pulse of decay with approximately 1 microsecond, with the depth of the exhibit on the high efficiency for the detection gamma ray, that capable of handling the high count rays. Organic scintillation phosphorus include the naphthalite, symbioline, anthracene, decay time, and other type of the phosphor, approximately 10 nanosecond. The type of the crystal is frequently even the detection of the beta particles. Plastic forests are made with the adding sensational chemicals. Plastic range for the decay of the content sources for the 3 phosphorus type of the approaching 1 to 2 nanosecond. The plastic that have the hydrogen content, therefore useful with fast neutron detectors. The schematic cross-section of one of the type of the photo multiplier tube, the shown figure 226 with the photo multiplier vacuum tube with the gas envelope containing photo cathode tube with the electrode coupled with the dynode to light with the scintillation phosphor liberates the electron from the photo cathode photoelectric effect. The electron are not of sufficient number to energy to detectable reliable potential electrode. However, in the multiphoto multiplier tube, they are attracted to the voltage drop of about 50 volts at the nearest dynode. The figure 226 with the photo multiplier tube schematic diagram: dynodes, electrons, gas envelope, incoming from phosphorus photocathode output pulse, and applied at high voltage. Photoelectrons strike with the first dynode with a sufficient energy level to liberate several new electrons, but the photoelectron, the second generator with the electrons, in turn with the trash with the second dynode with the large third generation group of electrons emitted. The amplification continues through the 10 to 12 state with the last dynode. Sufficient electrons are available to form with a current pulse with a suitable further amplification transistor circuit. The voltage drops between the dynodes established with a single external bias approximately 1000 volt DC with the network with the external resistor equalize the voltage drop. The advantage of scintillation counter efficiency with a high precision counting with a rate for the possible large attributed to the consequences of the extremely short duration little flash with about from the 10 to negative 9, 10 to 10 to negative 6 seconds. Intensive light flash with the amplitude of the output voltage pulse with the proportional energy of the particle response to the flash atom. Consequently, scintillation counter that can be used to determine the energy as well as the number of the excitation particle, the gamma, the photon, photo multiplier tube, the output with a very useful radiation spectrometer to determine the incident radiation energy levels. Summary: the operation scintillation counters is summarized. Installation counters summarize the radiation interact with the crystal center of the cup with the electrons to be raised with the excited surface site with the center of the DX size with the crystal emits with the photon visible light range. 3 casts with the phosphorus are used. The inorganic class, inorganic crystals, organic crystal, and plastic phosphor. The photos emitted from the phosphor interact with the photocathode, photomultiplier tube, and the releasing electron with the UV voltage potential electrode of the traffic strike with the nearest dynode with enough of the energy to relieve additional electrons. The second generation electrons are attracted to strike with the second dynode with releasing more electrons. The amplification continues for 10 to 12 stages. The final dynode, sufficient electrons are available to provide a pulse with a sufficient magnitude for further amplification. Gamma spectroscopy. Gamma spectroscope with radiochemistry for the measurement method of determining the energy for the count of the rate of the gamma rays made with the radioactive soap of the gamma spectroscope is an extremely important measurement that details now the gamma ray energy of the spectrum energy to determine the identity quantity of the gamma emitter of the present within the material. The equipment of the gamma spectroscope include the detector pulse with the multi-channel anodes, associated amplifier, data readout device with the detectors, normally with the sodium iodide scintillator count, figure 227 show the block diagram of the gamma spectrometer. You got your source crystal number 1, photo multiplier, high voltage preamp, linear amplifier, pulse sorter, timer, the data storage. Your oscilloscope that's got data readout with the spectrum chart recorder, chart driver, printer, and scaler. The multi-channel pulse height with the analyzer, the device with the separate pulse based on the pulse of each with the energy of the pulse height is referred to as the game of the pulse height with the proportional energy level of the game of the ray separation with the pulse of the based on the pulse height with the show of the energy spectrum of the game of the ray with the made with the multi-channel analyzer, typically 100 to 200 channels over the energy of the 0 to 2 million electrical volts. Output pull out with the pulse height with the game of the activity shown in figure 220 of the analyzer with the spectrum gamma rays made up with the U that can determine is called by the gamma pulse. Or you're summing the operation gamma spectrometer is summarized below. The gamma spectrometer, the scintilation counter normally NAI and the element NA and I multi-channel analyzer separated the pulse based on pulse height. The scintillated the radioactive material emits with the gamma and certain energy level to each for the pulse height corresponding to the different type of the atom. All right, miscellaneous detectors. Self-powered neutron detector. The very large reactor pan with the need to exist with the mounted neutron reflect with the various proportion over the core of the continuous power with allow quickly detection of the instability of the section of the core. Need broad development self-powered neutron detector that is small and inexpensive but rugged enough to withstand with the in-core environmental self-powered neutron detector requires no voltage supply with the operation figure 229. Figure 29 illustrates with a simplified drawing self-powered neutron detector. The thick central wire which undergo the emission without the neutral capture with the insulation of the grounded and off the ground from the center parameter grounded. Center wire of the self-propelled neutron detector is made with the material that absorbs the neutron undergo the radioactive decay with the emitting of the electron beta decay with the type of the material with the center wire of the cobalt, cadmium, rhodium, and vanadium. The good insulating material between the central wire of the detector case each of the time the neutron interact with the central roll wire to transform the wire atom the radioactive nucleus. The nucleus will be eventually decay with the remission of an electron because of the remission of these electrons become with more positively charged with the positive potential of the wire called the current flow of the resistor or the millivoltmeter may measure with the voltage drop called the resist electron current from the beta measured directly with the electrometer. There are two distinct aims with the self-powered neutron detector the very level of the instrumentation is required with the millivoltmeter electron or an electrometer with a meter of the material that is much greater than the lifetime of the boron or uranium-235 lining used in the wide-range fission chambers. One of the disadvantages of the self-powered neutron detectors is made of the material decay with the characteristic of the half-life with the decay of the rhodium and vanadium, which are the two most useful materials of the half-life with 1 minute and 3.8 minutes, respectively. The means of the detector cannot respond immediately to the chamber of the neutron flux. It takes about 3.8 minutes to reach the 63% of the steady-state value. The disadvantage occurs overcoming the cobalt, cadmium emitter of the which are the emitter of electron 10 to the negative 14th second with the neutron capture self-powered neutron detectors, cobalt and cadmium called the problem self-powered neutron detectors. All right, your wide-range fission chamber. The fission chamber of the neutron include and due to the fission with a detect neutron of the chamber that is usually similar to the construction of the ionization chamber except for the coating of the material is highly enriched with the uranium-235 of the neutron interacts with the uranium-235 that causes the fission one of the two fission but the fragments entering the chamber of the fission with the fragment embedded within itself with the chamber of the wall with one advantage with the using the uranium-235 coating rather than the boron fission fragment has much of the higher energy level alpha particle of the boron electron reaction. The neutron induced the fission of the fragments due to the boron more ionization of the chamber of the per interaction to do the neutron and do the alpha particle to allow the fission chamber to operate with the higher gamma of the field with the income stay with the ion chamber of the boron lining. Fission chambers are often used with the correct with the indicating device for the pulse of the device simultaneously are especially useful for the pulse chamber to do the very large pulse. So the difference between the neutron's gamma ray that pick up with the fission chamber with the dual use often use the wide range chamber with the nuclear instrumental systems. Fission chambers are also capable of operating over sort of the intermediate range of the neutron levels. Activation foils and flux wires, whether the necessary for the measure of the reactor neutron flux rate and profile section of the wire of the foil is inserted directly into the reactor core of the wiper. The wire of the foil is remained with the core with the length of the time the required activation desired with the cross section of the flux of the wire of the foil must be known to obtain the accurate flux profile after activation. The flux wire of the foil is rapidly removed with the reactor core actively counted. Activated foils can be discriminate energy level, placing the cover over the foil with the filter out with the absorb with a certain level of neutrons and then cadmium cover. They're typically used for the purpose of the cadmium effective filters out of all thermal neutrons. All right, photographic film. Photographic film may be utilized with the X-ray work of the disometer with the film temperature with the dark when they expose the radiation. The general darkening of the film used to determine overall radiation exposed with the neutron scattering producing individual proton recoil will track with counting the track yield of the film exposed with the fast neutron filters to determine the energy, the type of the radiation. Some of the typical filters use aluminum core, copper, magnesium, and lead. These filters provide various amounts of the sheathing attenuation, the different energy by comparing the exposure on the different filters and proximate spectrums is determined. Summary: the description of how self-powered neutron detector, the wide range fission chamber, the flux wire, and the photographic film will detect radiation summarized detected. Your self-powered neutron detector, the sensor will be made with the neutron that absorb the materials absorbed with the neutron undergo the beta decay, absorb the beta decay, the group of the remaining the atom of the wire much more the positive charge voltage and potential steps over the current flow with the resistor, which is measured for the each for the millivoltmeter electrometer of the wide range fission chamber. The neutron to interact with the uranium-235 coated chamber with the covalent fission with the uranium-235. High positively charged fission fragments interact with the detector. Gas caused ionization. Electrons produced with the air collected with the balls of the electrode flux wire. Wires inserted directly with the core becomes activated with the neutron flux. With the desired activation time is reached with the wire is removed from the core with the counter photographic film. Detects the total radiation depth of the darkening of the film. The darkening of it determines overall exposure. Fast neutron exposure determined by counting individual proton recoil tracks. All right, circuitry and circuit elements. Terminology, understanding how the reactor power monitoring detection equipment that works with the required for the working now with the basic terminology. Single to noise ratio, the ratio of the electrical output, signal to electrical noise generated by the cab to run an illustration. Discrimination and radiation detection circuits refer to the process of distinguishing between different types of radiation of the pulse with the pulse height, with the discriminating circuit to select the minimum and maximum pulse height that is to be counted. Analog. The analog is defined a mechanism of the data with a continuous variable physical quantity supplied with immediate range of the output with the intermediate the range of the analog current due with the wide range of the flux measure with the U with the logarithmic circuitry required with the indication single scale with the instrument analog is U with the contrast with the digital refer to the circuit with the magnitude of the signal carries information. Figure 30A show the illustrate the example of the analog display. 30B illustrate the digital display. Figure 30A show the analog. 30B show the digital. The logarithmic is defined with the exponent to indicate the power to which the number of the derivative provided with the given in the logarithm 100 to the base of the 10 to the 2. The discussion of the nuclear instrument with the term referred to the electronic circuit over the source of the intermediate range of the range of the utilized the logarithm due to the wide range of the measure of flux with the necessity of the measure of the flux with a single measure scale. Your reactor period is defined with the amount of time normal and cycle required with the neutron flux chain power to chain with the factor of the factor of the E or 2.718. Decade per minute or DPM, the rate of the circuit with the important range of the rate with the information displays, rate and meter with the decays per minute with the meters that indicate how fast the reactor with power with the chain with the decays and the power with the 10 each minute. Scalar, the term that refers to the quantity with the capable of being represented on the scale of the neutron flux with the source of the range, intermediate range, and power range meters. Alright, components. These ranges are used to define with the power level of the reactor throughout all the full range reactor operation. The source of the range, intermediate range, power range. The source of the range normally used with the proportional count with the intermediate power range for the use of ionization chamber and the compensated with the ionization chamber. Use the intermediate range, the power range for the use of the uncompensated ion chamber. The use of the three different ranges makes use of the sum of all of the following type of the components: pre-amplifiers and amplifiers. Radiation detectors output signal with usually weak with require amplification before they can be used with radiation detection circuit with the nature of the input pulse. The discriminator determine the character of the preamplifier. Amplifier must have two-stage amplification used in most detection circuits to increase signal-to-noise ratio. Figure 31 shows how the two-stage amplifier increases the signal-to-noise ratio. Signal volt, low and cable, amplifier noise. The radiation detector located in some of the distance readout with the shield coax of the cable to transmit the detector output for the amplifier. Output signal of the detector may be as low as 100 of the volt to the gain of the 1000 and even increase the signal of the 10 volt with which the unusable output of the pulse voltage. This always pick up the noise along with the cable to run. The noise can amount to 1,000th of the volt. The amplification where done with the remote amplifier 100th of the volt pulse signal would be 10 volt. The 1,000th of the noise volt would be 1 volt. The signal noise ratio of the 10 could be significantly reduced dividing the total gain of between the two stages of the amplification preamplifier located with the detector. Remote amplifier could be used with the preamplifier virtually eliminates cable noise because of the short cable the length of the total gain of the 1,000 preamplifier gain to 100. The amplifier gives a gain to 10. Output signal of the preamplifier is 1 volt. Signal transmitted of the long cable to run 6 between 1,000 volt noise. The amplifier amplifies 1 volt pulse signal with the 1,000th volt noise signal factor of 10. The result is 10 volt pulse signal with the 100th volt noise signal to give it the single noise ratio of 1,000. Or your discriminator circuit. The discriminator circuit is selected with the minimum pulse height with the input pulse exceeds the discriminator press step. The discriminator generates the output with the pulse, and the discriminator input with the normally amplified shape. The detector signal is the analog signal to become the amplitude with the proportional energy incident with the particle of the base diode circuit. The simple performance of the discriminator figure 32 show the base bias diode discriminator circuit is shown circuit is associated with the input and output signal. So the voltage, power, and time, the rectifier diode, resistor, capacitor, resistor, voltage, output. Diode 1 shown in the cathode connect with the positive voltage with the positive voltage diode with the conductor with the contact volt with the crowd with the anode power with the respect with the cathode is along with the voltage anode left than cathode diode 1 does not conduct therefore no input at some point with the anode voltage exceed with the base positive voltage diode conducts input signal level the path of the output figure 32 illustrates the input output signal how the discriminator acts and eliminates all pulses below the preset level of the output pulse with the circuit have the same relative of the amplitude of the input pulses. Alright, logarithmic meters. The radiation protection of the circuit can remember the pulse, the raise of the very offer of the wide range of the current output of the ionization chamber that may be from the 8 orders of the magnitude. For the example, the range that may be from 10 to negative 13 amps to negative 5 amps. The most accurate method to display with the range, but to utilize the linear current meter, several and with the several scales and the capability to switch with those scales. This is not practical single scale, which covers the entire range of the scale is referred to as the logarithmic. Logarithmic outmeter must be provided with a signal of proportional logarithmic input signal easily done with the using the diode with the input signal from the ionization chamber. The voltage across the diode equal to the logarithmic with the current through the diode with using the principle of the simplified circuit with the shown figure 33. 33 if the current in the ionization chamber the current with the voltage proportional to the logarithmic current. Alright, show the voltage output with the current, the ionization chamber, the diode, and the electrometer, the voltage log meter. Alright, your period meters and startup rate. With the mini applicator, the essential with the node, the rate of the chamber, the power of the rate of the normally increase with the degree with exponentially with the time of the time constant with the time of the chamber referred to as the period with a period of 5 seconds being the value of the chamber, the rate factor of the 2.781. 5 seconds is shown on the basic period with the meter, the circuit with the ion shape with the diode with the DC amplifier capacitor resistor output with the output with the is equal to 1 period over the 1 time constant. Placing the signal through the RC circuit to show that the voltage is proportional and reciprocal period with the current through the ionization chamber to count with no current flow with the resistor over the output voltage 0 that correspond with the infinite period with the ionization shape of the output current changes. Voltage transistor aircraft with the capacitor receive the current flow through the resistor R with the more rapid the transit the greater the voltage drop across the resistor short period. Rate information displayed with the meter decay of the pyramid and then into the use of the operator monitoring the rate of the chamber power during the start of the term the start of the startup rate with the SUR the equivalent equates the reactor bearing period during the equations extends. The startup rate is equal to 2606 over the time or startup rate of decay of the pyramid with a constant 2606 over the reactor period. And second, the reactor operator adjusts the control rods over the upper limit of the DPM 1 DPM is not with the exceed the only all out of the orderly increase with the reactor power. Alright, summary. The summary changes range of the proportional count with the intermediate range of the compensated ion chamber, the power range of the uncompensated ion to the term that you would describe in the electrical circuit is summarized below. But the circuit terminology summary: signal to noise ratio of the ratio electrical output with signal of the electrical noise generated, discriminator selected, minimum pulse height with to be counted an analog mechanism which the representative of the continuous variable physical quantity, logarithmic exponent that indicate the power, the number, the rate of the produce, the given the number, the reactor period, the amount of the time required with the neutron flux chamber, the factor E, decades per minute, is the rate in which the neutron flux is changed with the power over the 10 in each minute. Scalar measurement according to the capability of being represented on scale. Startup rate with the rate is the main neutron flux charging measured the decades per minute. Or your source range nuclear instrument. Source range instrumentation normally consists of the two redundant of the count with the rate of the change of the E with the highly sensitive proportional count of the associated signal measuring the equipment of the channels of the typically over the U with the count range of the 1/10 of the 2 6 for the count per second with the vary with the base on the reactor design of the output with the display with the meter with the term with the logarithm count rate. Source range instrument also measures the rate of the chain with the count rate of the rate of the chain with the display with the meter with the term with the started up with the -1 to positive 10 decades per minute. The particular function normally associated with the such of the range with the instruction instrument because of the inherent limitation of the range, however the interlocks may be incorporated. Many reactor plants have time with the necessary to play for the source of the range of proportional counter, leave the shield with the reduce the gamma flux of the detector, serve for the two function, create with the low sensitive detector, the B with the A with the detector life, with another mean for the width of the detector life, that is extend with the disable the high voltage power supply with the detector, short with a single lead with the neutron flux with the path for the intermediate range, with another sum of the reactor plane with the more provisions, moving source range detectors from the operation proposition position, reduce the neutron flux level, the flux level increasing above the source range. Figure 35 show the typical source range changing with a functional formula. Tend to be the B-line proportional counter of the power supply, linear amplifier, discriminator, pulse integrator, log counter, amplifier, counting rate, meters, counts per second, and differentiator, startup rate per minute, decades per minute, control rod with inhibitor. B10 or the borium trifluoride gas-filled proportional counters are normally used with the source range detector proportional counter output with the form of the one pole with every ionization event. Therefore, the insert of the random pulse, verifying the magnitude representation, neutron, and gamma ionization events. Pulse height may only be a few millivolts for the load is too low directly without amplification. Linear amplifiers input the signal with a factor of several thousand with the ratio pulse for the height, several volts. The discriminator exclude the passive of the pulse for the lower left and the predetermined level of the direction of the discriminator to exceed the noise level of the gamma pulse with the level of the magnitude of the neutron pulse for the pulses are sent with the pulse of the integrator, which are the integrator of the signal and the proportional logarithm and counter. The log counter rate amplifier amplifies the signal which varies directly with the logarithm pulse of the rate of the detector. Logarithmic count rate is displayed with the meter with the logarithmic scale per second. The logarithmic count rate signal with the differentiator bench for the rate of the chamber, the neutron flux of the differentiator output of the proportional reactor appear with the value of the reactor appear with the inversely proportional to the actual rate of the chamber, the reactor power with the relief, the power change factor of 2.718. The power rate chamber is based on the factor of 10 with the decay of the per minute with the more meaningful the reactor operator. Therefore, the output differentiator is converted to the reactor period with the decay of the per minute. There, the meter scale used. Summary: the purpose of the source range component is summarized below. Source range instrumentation summary: the linear amplifier amplifies the input signal factor several alpha and rate for the pulse height with the several volts. The discriminator exclude with the passive pulse with the left and to be determined level of the pulse integrated. They provide the output signal proportional logarithmic count rate, log count rate amplifier applied with the signal of the display with the meter differential provide the output signal proportional rate of the power change. Intermediate ranging nuclear instrumentation. Or your intermediate range nuclear instrumentation consists of the middle with the two redundant channels that exceeds for these channels of the made up with the boron line board and gas filled with the compensator with the ion chamber with the associated signal measuring equipment with each for the output of the current produced with the neutron flux. The compensated ion chamber that is utilized with the intermediate range with the cover with the current output with the proportional reliable stable neutron flux. The compensator the signal of the gamma of the flux with the rate of the indication also provided the measure for the rate of the change neutron level, the rate of the chamber, the display with the meter with the image of the rate of the decays per minute, 1 negative of the 10 positive of the decay per minute. High startup rate with either channel may be inactive with the protective action may be due in form of the control rod, weather draw with the inhabitant alarm, or startup of the reactor type trip. Figure 36 shows the typical intermediate range of power supply of the compensator, the chamber, the logarithmic amplifier, the power level of the meter, the full power or amperes. Differentiator to start up the rate meters, decades per minute, protection, reactor protection system control rod with rod inhibitor. Typical compensator with the ion chip with the output with the analog current with the range from the negative 11 to 10 to negative 3rd amplitude vary for the reactor design with the logarithmic log n amplifier logarithmic current amplifier converts the detector for the output of the signal proportional logarithmic of the detector current with the logarithmic output proportional with logarithmic neutron level. Determination of the rate of the chain logarithmic neutron level, the source of the range, the complex of the differentiator measure for the reactor appear with the start of the rate of the start rate, intermediate range is more stable with the recover the neutron level, the signal of the subject less so than the large variations. For this reason, the intermediate range is the start of the is often used to input of the reactor protection system. Or the reactor protective interface that provides signal with the protective action. Examples of protective actions include the control rod, withdrawal, interacts, and startup reactor trips. Some of the purpose of the intermediate range component are summarized below. The intermediate range instrumentation, a summary with the log and amplifier converts the detector output with a signal proportional log with the detector current. Differential provided the output proportional with the rate of the change of the power. The reactor protection interface provides a signal for the protective actions. Power range nuclear instrumentation. Your power range nuclear instrumentation normally consists of 4 identical linear power levels of the channel with the originate with the 8 uncompensated with the ion chamber, the output of the steady current with the neutron flux, uncompensated ion chamber, the utilize with the power drain with the big of the gamma, the compensation for the necessary with the neutron gamma, flux ratio is high with the high neutron gamma, the ratio of need with the number of the gamma is insignificant compared with the number of the neutrons. The output of each of the range of the channel with a directly proportional each will react with the power with a typically cover with the range with them 0% of the 125% of the full power vary with each of the rack output. Each of the channel is displayed with the meter determine the power level of the percent of the full rated power of the game. That each of the instrument is adjustable to provide with the mean of the calibrating output of this adjustment is normally determining the UV of the place plant heat balance. The proactive actions may be initiated by a high power level at any two channel within two coincident operations. For the power range channel with the power supply with the UCIC limit line amplifier power level meters, the startup rate, triplet inhibitor reactor protection system with power flow and monitor. Your two detectors, each channel with a functional connected to the pair will achieve their measure within some of the two detectors. The output drive of the linear amplifier amplifies the signal to use the level of the reactor projects the interface to provide the signal with the protective action. Examples of protective action signal provide power range include signal reactor protection, simple system with selective value, normally 10% of the reactor, disable the higher startup of the reactor, triple the signal to protect the chip of the reactor power level to exceed the predetermined value, signal for you for the reactor control site and control system, signal to pour power to control flow circuit. Summary: gamma compensation is not required with the power range of the sense of the neutron's outer gamma. The best the large number of the gamma. There are significant purpose of the power range component summarized below. Power range instrumentation summary line amplifier amplifies signal to useful level. Reactor protective interface provides signals for protective actions. Alright. Department of Energy Fundamental Handbook Instrumentation Control Module 7 Process Controls.